Okay, it says fill in the blank with the appropriate word, phrase, or symbols. Numbers of the form 2 to the 2n plus 1, where n is a natural number, are known as Fermat's numbers. That is the correct answer. Do you know who Fermat is? Anybody know? Fermat is a mathematician that was around the 13th, 14th century, I think. I can't remember the numbers. Okay, 16th. And he was the one that tried to prove that Pythagoras' theorem could be used with all numbers. And it didn't work. And he tried to prove it and tried to prove it and tried to prove it. And he did say he proved it. And he wrote it in the margin of one of his notebooks. But they never found the notebook. Okay? They found a note that says the margin of one of my notebooks or something, the margin of this book or whatever, but they never found it. Now, a guy in Cambridge, England, or England, at the University of Cambridge, does it mention him? He proved it about 10 years ago. Who? No. Keep going. See if it says anything about Cambridge in England. It's a guy that looked like Bill Gates with blonde hair. Curly hair. He had glasses. He had the whole... Can't think of his name right now. But he says he proved it, and he proved it and submitted it to the mathematicians of the world or whoever does the... And it said it would take 6 to 10 years for them to prove it. For them to go over the proof and say that he proved it. Let me look it up for you so you'll know. This is not a test question. You do not have to worry about it being on the test. I didn't even know that. I didn't even know Fermat was in there. Latest on Fermat's theorem. Where is his name? I can't remember his name. When I see it, I will. Andrew Wiles. There it is, right there. Wiles' proof of Fermat's last theorem. Andrew Wiles' proof is a proof of the modularity theorem for systematic elliptic. There, I was thinking of dang old. Yeah, epilepsy. Curves released by Andrew Wiles, which together with Rabi's theorem provides a proof for Fermat's last theorem. So that's something you might want to look at. There he is. Doesn't he look like Bill Gates without black hair? I think he does. Anyway, that's him. He worked on it for years. And there's Fermat's theorem. A to the n plus b to the n is equal to c to the n. Now that is pretty much go away. Okay. A squared plus b squared is equal to c squared. And what is this? That's Pythagorean theorem. And it is theorem. That is for right what? Right triangles. A squared plus b squared is equal to c squared. And Fermat said that you could go through and do it with anything. So 2 squared plus 4 squared is equal to, let's say 6 squared. He said that you could do 2 to the third plus 4 to the third is equal to 6 to the third. But he found out that that didn't work out too well. And thus, he started trying to prove it. And he said he had a proof and wrote it in the margin of this notebook, and they never found it. So that's what that has to do with, and now you're a little bit smarter about Fermat's theorem. And it's not Fermat's theorem, it's Fermat. Okay, like
Not dumbass, but Dumas. You know the author Dumas that wrote, what did he write? About the prison break. What was the book about the prison break? But anyway, people call him Bill or William Dumas. And it's not William Dumas, it's Dumas. Fermat. Hubert said ass in class. I hear it now. Mr. Lassiter, I can't do anything right. You ever feel like that sometimes? You just can't do anything right. Dumas. Alexandre Dumas. He wrote, not that. He wrote The Three Musketeers, but he wrote, where is it? Well, he wrote a famous, I guess it's Cristo. I guess it's Monte Cristo. It's about a prison break. But anyway, he also wrote The Three Musketeers. Anybody notice anything different about Alexandre Dumas? Anybody notice anything different about him? Nobody gonna take a guess? Oh, I'm sorry. Well, anyway, he wasn't white. A lot of people don't know that. He wasn't white, so he was black.
I didn't know if he was Spanish.
He was purple. Yep, he was black. And if you ever watched, have you ever seen the movie about, you leaving us? Why are you leaving us? Did I make you mad? Uh-oh. So, what happened?
They ran out of gas and they got a baby with them and they don't have no ever since.
Let me guess, younger brother.
He's 17 and she's 20.
And guess what?
They've been married a year and a half.
Oh, me. That's not going to head in a good direction. I hope it does. But
Oh, she's pregnant again, so we'll see.
okay, good luck. Last name. Last name.
Rochester.
Rochester. Remember that. Rochester. Where are they? Anyway. You ever seen Django?
Yes.
Django, there was a slave named D'Artagnan. And D'Artagnan is a famous character from what? Thank you. You grew up like me. You didn't grow up where they taught you for the test. They just taught you. Yeah. That's why we got people that don't know anything. D'Artagnan was the main character in The Three Musketeers. Well, in Django, the Leonardo DiCaprio is saying stuff, or the guy that hangs around Django, the slave owner that owns Django or did own Django and made him free, he says, I just wonder what Alexandre Dumas would think about a black man named D'Artagnan. And Leonardo DiCaprio, who's a dumb redneck, he goes, I don't know, I guess he thought he'd be stupid. He was probably a dumbass too, or something like that. Something like that. I can't remember his exact word. And my guy turned around and said, Mr. So-and-so, did you not know that the author of The Three Musketeers was Alexandre Dumas? Well, yeah, I knew that. And that he was a black man. So it's kind of ironic in that scene that the dumb redneck didn't know that Alexandre Dumas was black. And I bet y'all didn't know that either because y'all still thought his name was Dumbass. Huh? I didn't even know him. But who was the woman that sat on the back of the bus during the 1960s? See? See? You know that. Because that's a test question on one of those tests that you're coached for. But you don't know who Alexander Dumas is. Dumas. But that's why you say Fermat instead of Fermat. That's that old Fermat's theorem. Have you got a tooth in your head? All right. So don't worry about Fermat that much, whoever asked that question. We're going to get on to some more good questions. I'll tell you, when I pull up a homework question and it's a test question, I'll tell you. Okay? That one, test question. This is 5.137/13. Where's Miss Beasley at? She not in here? Find the prime factorization of 1287. Do it. Hurry up. Draw your chart. 2, 3, 5, 7, 11, and sometimes 13. No, I'm off the clock. 1287. Prime factorized. I'll write right here. Can you see this? Hold on. 1287. Come on, you can do it. How about that? 2, 3, 5, 7, 11, and sometimes 13. Now, did any of you, no sneezing please, do it again, you have to leave. Did anybody pull up the divisibility rules that I told you to pull up a copy? You're the one. Okay, you did pull them up? Did you print it out? Okay. Anybody else? Okay, what's this divisible by? How do you know? I thought it was divisible by 9.
It is divisible by 9.
Yeah,
First
I
one.
mean,
And after that, it's divisible by 10.
Why? How did you know it was divisible by 9? You know how I know? I look at the last digit. The last digit is a 7. What's the only number in your multiplication table to end in 7? 27. So you know that 9 will go into it. Yes, ma'am?
My teacher last semester said it added together, they added 18.
Yeah, that's another one. And I think 9 also, if you add them up, and you have to read things. That's why I gave it to y'all, but evidently it causes so much work. So I guess I got to print it out for you and give it to you, don't I? No, I'm not. No, I'm not. Okay, so I'm going to divide by 3. Why am I going to divide by 3? I thought you said it was divisible by 9. 9 is not what? It's up there. And I told you these were the only ones you could use. So, 3 will go into 12 4 times. 3 will go into 8 2 times. And that'll leave what? 27. And then 3 will go into 27. It's a miracle. Now this one ends in 9. The chances are you could probably divide another 3 in. What else? 13 maybe? I don't know. What is the rule? Can you add those numbers up? 4 plus 2 is what? 8. 8 plus 9 is what? 17? That don't help us. So, what about 9? Huh? 3? 3 going there 1 time, 4 times, 3 times? It's a miracle. So, you could pick out, you only got 5 numbers to choose from. Because most of the time, these numbers will go into it before this one will. Use this one as the last result. So, 3. And that gives us 1, 4, 3. Think 11 will go into it? Dang old, what, 13 times? It's a miracle. Y'all are getting so smart. And then 13, 1, and there is your prime factorization. 3 to the second power
times 11 times 13.
And I bet you $1 to a donut hole that that is the answer. Where's the pizza? I thought y'all were bringing the pizza today.
We thought that's why you were late. I was just
All right, I'll bring y'all something next time if I'm hungry. Look at there. 3 to the second times 11 times 13. You want me to go to Krispy Kreme and buy you the donut?
Heck yeah. Some donuts.
Some donuts. I'm just one. So you're going to eat 2 or 3.
When you get them punched, you'll eat them at once.
All right. So let's hit similar exercise, and I'm going to let y'all do that. 572. A lot of people say, how many times do we need to do these? I'd say at least 100.
Till you get it right.
Till you get it to where you can do it without thinking about it.
You said 572.
Yep. Where is everybody? Why do they quit coming today? What are you doing with a calculator? Give me that thing. All y'all are. So, since all y'all got it wrong already, and half of you haven't started on it, 572, and I'm going to divide that by 2, 3, 5, 7, 11, and sometimes 13. Which number shouts out, I'm divisible, I can go into this number? 2, because it ends in what? 2. Now, I'm not asking you to be a rocket scientist and try to figure out how many different, if you know it ends in 2, divide it by 2, because what's that going to do? That's going to make a bigger number into a what? I got people, well, I know 2 goes into it. I wonder if another number goes into it. You need to do the 2 and then worry about the other stuff later. You trying to be all smart and everything. Divide it by 2, huh? What? All right. Divide by 2. The reason I'm dividing by 2 is because I want to keep it simple, Sherlock. Okay? I want to keep it simple. 2 will go into 5 2 times. That leaves a 1. 17. 2 will go into 17 8 times. Leaves a 1. 1, 2, 6. Oh, look at there. Another even number. Divisible by 2. 143. Okay, now we got a 3. Got a 3. What multiplication number ends in 3? No, that ain't going to work. That's too easy. 13 is a prime number. How about 63? I have no idea. Let's see what happens. 7 will go into 14. Yeah, that's good. That won't help. So that won't work. 3, no. 11, didn't we do 11 into 143 a while ago? Okay, how many times? Dang old 13 times. 11, 13, 13, and 1. And we feel good about ourselves, so we don't have to. Let's see, how can I do this? Oh, I put it on Facebook. So we feel good about ourselves. So we do not have to hold on, just bear with me. No, there it is. So we don't have to wear sunglasses inside. Anybody see that? Can you see it? I don't know why this. This is at El Patron's. Ooh, there's my pigs again. Hold on. Where's my? Oops, there's cows. Sorry. There. This guy was sitting beside me at El Patron's. And I watched the whole time. And he sat and ate in El Patron's with his back against the windows, wearing no sunglasses.
You like
Tell
your
me
own
why.
picture?
Tell me why. Girls, you ever meet a guy like that? Run. Run, run, run. Because behind those sunglasses is issues. Very bad issues. I'm just telling you. Anybody ever met somebody that wore sunglasses inside? Tell us about it. Am I not right?
My boyfriend has a house. Either they think they're super cool.
Uh-huh.
Trying to in their eyes.
No, they got issues.
My boyfriend doesn't go through this one about himself. I thought he was very skeptical.
They look like a DA if they're walking around inside with sunglasses
Thank you.
on.
That's what I tell him all the time.
I mean, what does he look like? Okay. All right. So if you feel good about yourself, you don't have to wear sunglasses inside. Women do it too. It's called Oompa Loompas. Orange face, white neck. You ever seen those people? You ever seen the ones with orange face? Period, because they've been baking in the what you call it?
You got transition lenses in your glasses, you wear sunglasses on the inside.
They don't turn. They turn white. Mine are transition. Mine turn white or clear. I'm talking about these.
Those were sunglasses.
Those are Terminator sunglasses. Those are Terminators, okay? Those ain't no prescription sunglasses. Oh well. And I couldn't get a good picture of him. I wanted to, but he knew I would be taking a picture of him. So. Oh well. Okay. So let's check 572. What did we say 572 was? 2 squared. Shift up. 2 squared times 11 times 13. Look over there. We got it right. My turn. Tell you what. We feel good about ourselves. And that's that one. We done that one. Okay. So let's go to the homework and let's pick out some more, because I'm going to drill these things in your head over and over and over. I thought I pulled up. Did I not pull up? There it is. Okay. 155. Homework. And 5.1. And I'm just going to go to number 7. I'll pick a good test question out. Not that one. Not that one. They're asking the divisibility rules. Okay, there's one. Now let's do 104 and 130. 2 at one time? Yep, this is how you do it. And it's also asking for what? And least common multiple. So here I go. 104 and 130. All right, I want you to do as much as you can until you get to a stopping point, and then meditate. Oh my God. No snipping before I do. I Need to pull the roll up. Count all 5 people that are here today. I gotta go pick up my son. Math 155. Set attendance. All right. Bailey, Beasley, Clemenshaw, Correll, Dizdar, Flannery is here, Granger is here, Hayes is not here, Lassiter is here, Richardson, Rochester, Satterfield, Richardson's not here, Rochester's not here, Satterfield, oh, she was, thank you. Satterfield, Tatum, Taylor, Thompson, Walker, and Williams. All right, that's done. I ain't got to worry about that no more. All right, so here we go. What am I going to divide by first? 2. Why? Because they both end in an even number. So 2 will go in there 52 times, and 70 what? Or 65. Okay, is there any number that will go into both of these? How much? 13, let's see. 13 will go in there 4 times. 13 will go in here, what, 5 times? Uh-oh, we got a problem. What's the problem? One's prime, one's not. But what am I trying to get you to see? Nothing goes into what? Both of them. So out here, no number goes into both. At this point, the real math stops. The real math stops
when the real math stops and you cannot divide into the two numbers, you have just gotten the greatest common divisor. What's 2 times 13? Now let's talk about the definition of the greatest common divisor. What is 26? The greatest common divisor is the biggest number, big N, the biggest number that will divide into what? 104 and 130. Now write that down because you need to know that definition. You take your calculators out and divide 104 by 26. What do you get? Okay. Take 130 and divide by 26. What do you get? 5. Try another number. Try 30, 36, 32. There is no other number that will go into both. That is the biggest number right here. Biggest number that will go into 104 and 130. But what's the least common multiple? The least common multiple is the smallest number that 104 and 130 will what? Divide into. And we're going to write that number right here. And we're going to explain in just a minute. So, let's keep going with magic math. And I'm going to do magic math in green. Magic math means that I can divide. If I can't divide, I bring down. But I want all ones on the bottom. That's what I want. That's the goal. Get all ones on the bottom. So what can I divide into? Still using my numbers. 2, 3, 5, 7, 11, and sometimes 13. What numbers can I use to divide into 4? 2. So that gives me a 2 here, and this comes down because I can't divide 5
Priority
by 1.
1 message coming in on secured channel.
I can't divide 5 by 2, so I just bring it down. What else do I need to divide by? Another 2. Hey, I got one of my 1s. But that 5 just comes down. Now what do I divide by? 5. And guess what I have? That comes down to 1 and 1, and I got my 1s. When you have your 1s, guess what you have? Your least common multiple. And your least common multiple is right there. Now I'm going to show you a trick I learned in the war. Anytime you can take 2 by 5 out, do it. Because what is 2 times 5? Anybody, a 5th grader, a 2nd grader can multiply by 10. So let's look. I'm going to take another marker. Do I have a 2 times 5? Yeah, right there. There's 10. And then what other number is giving us problems? 13 is giving us problems, but we can multiply 2 times 13, can't we? What's 2 times 13? 26. So I'm going to take this guy, and I'm going to say 26, and this is 10. What's 10 times 26? Good gracious, y'all are quick. No, everybody can multiply by 10. So get your big number, multiply it by 10, you just add a what to it? A 0. So we got one more number. You just said 260 times what? 2. So what's 26 times 2? 52. Add a 0 to it, what do you get? 520. So 520 is the smallest number that 104 and 130 will go into. Let's check it. Take your calculators out and divide 520 by 104. What do you get? It's a miracle. Take 130 and divide into 520 divided by 130. What do you get? It's a miracle. Now, which one is the most important? Ali, you were choosing that red marker. What does that red marker mean? It's very important. That guy right there is very important for section 5.2. Does anybody know what 5.2 is? What's another word for rational? Huh? No, irrational is the opposite. What is another word for rational? What is another word for ratio? It's that thing that nobody likes to add or subtract. Starts with a F. Fractions. Is it 5.2 fractions? Okay, 5.3. My bad. 5.3 is fractions. That's what I'm getting you ready for. I don't care about integers. That's easy. I can cover that in 30 minutes. All right. But 80% of your test is going to come from 5.3. So write that down. And you cannot do 5.3 without this guy. So you better learn how to do this. So let's check it and see what they come up with. What did we get for the first one? That's what I hear. There we go. Enunciation. Fantastic. You are a winner. You do not need $10,000 of video equipment in the $1,000 car. What is the lowest common multiple? Least common multiple? 520. You do not need smokestacks on your truck. You got that one right. All right? Y'all try that one. We will do these until you are sick of them. 165 and 297. 165 and 297.
Julie. Julie. Guess what day it is? Julie. Julie. Guess what day it is? Guess what day it is? Guess what day it is? Anybody? Anybody? Guess what day it is? Guess what day it is? Anybody? Anybody? Mike. What day is it, Mike? Woo-hoo!
I love this chick.
Mike.
She goes,
What day is it, Mike?
it's hump day.
Oh, come on, I know you can hear me. Listen, guess
Right
what
there.
today is? Listen, guess what today is?
Here it comes.
Listen, guess what today is? Listen, guess what today is?
It's hump day.
Hump day! Woo-hoo!
I love that commercial.
It's hump day.
Hump day! Woo-hoo! Uh-oh. Mike. What day is it, Mike? Uh-oh. Mike. What day is it, Mike?
It's hump day.
Hump day! Woo-hoo!
You know what's bad about it? Huh?
It's hump day.
Hump day!
I know, but it's great. I love hump day. I love the hump day. Look at this. He's actually got a couple of more. Here's another one.
Uh-oh. Guess what day it is? Guess what day it is? Oh, excuse me, ladies, coming through. Guess what day? Ooh, popcorn! Hey, guess what? Popcorn! Oh, you put extra butter, huh? Nice. What day is it? What's today? What? What? Do I have popcorn in my teeth?
I mean, we talked for a long time.
Hey, Mike! Guess what day it is?
It's
Movie day! Turn off your cell phone!
You know him.
Let me call you back. Yeah, we work together.
Is that your mom, man? Movies with your mom. I dig it, dude. That's nice. Movie day?
Was that his wife or his
Give
mom?
it up! Movies!
And then they got the Super Bowl. Did you know this? Oh, wait a minute. That's not the right one.
Okay, so let's throw
Let's
it
back
to our
up.
sideline.
No, let's don't. Let's back up. Hold on. You got to do number one first.
Oh, guess what day it is? Guess
No.
what
Is this number one? Yeah, this is number one.
day it is?
Oh, no.
Game day? Yeah!
What are you doing there?
I'm your new sideline reporter, Terry Bradshaw, the Ball Bomber. Woo-hoo!
Oh, my God. He's worse than Jimmy. Oh.
Then day two.
Let's go back to our new sideline reporter.
Terry, where's Mike?
You mean Michael Strahan?
Yeah, I want to talk to a real football legend.
Hey, Kimmel, I got more Super Bowl rings than you got humps. You got that?
Well, I got more humps than you got hair.
What did he just say?
Burn!
And then you got day three.
Let's check back in with our new sideline reporter.
Oh, hey, Terry Bear.
So, have you talked to any players?
Nope, but I talked to the nachos guy and the cotton candy guy.
But what can you tell us about today's matchup?
I can tell you one thing. Nachos and cotton candy do not match up at all. Oh, I gotta lie down.
Do you know that the guy that does the voice for him, they've already got him lined up to do 3 or 4 other commercials?
Let's go back to our
Ain't
new
that something?
sideline.
That's the funniest Geico commercial. Some of them don't make any sense whatsoever. I just figure that might bring a little bit of relief to y'all knowing that it's hump day. Okay, let's get back to work. Here we go. Hump day! I didn't have anything to drink. 165. What? And 297. Two, 3, 5, 7, 11, and sometimes 13. All right, so what are we going to divide by? 3. I'm going to change it back to black because I want to. So 3 will go into there. 3 will go in there 5 times and then 3 times. 3 will go into there 9 times and 9 times. Huh?
Yeah, 3 and 15 is 5 times, so 55.
Oh, I'm sorry. I was thinking of 27. 3 times 3 going to 29, 7 times.
I don't know what I was thinking, I'm sorry. 7 times, right?
No, it's 55 is what we're talking about. It's supposed to be 55, not 53.
Oh, well, this one's 75, right?
99.
Okay, I'm just gonna start over because right now my mind is not working. Okay, I'm gonna start over. How about that? 3 will go into 6. No, I didn't. I had T. That's all I had. 3 will go into 16 5 times. That will leave 1, 15. That will be fine. Now, I don't know what I had to begin with. 3 will go into 29 9 times. That'll be 27. And then 99, right? Okay. 11, dang old 5 and 9. Now what happens here? The real math what?
Stops.
Real math stops. Real math stops. And your least greatest common divisor is 33. Now I'm going to divide by 5. And that will give me a 1 and a 9. 3, a 1 and a 3. 3, 1 and 1. So 3 to the 3rd power. And times 5 times 11. Now, there's really not any easy way to multiply this without a calculator, so we're going to try to do it because we don't want to rely on the calculator because we would like to be able to think as we grow older. So, I'm going to multiply, I'm going to take this 9 right here, 3 to the 2nd power, I'm going to take that out. I'm going to use that. 9 times 5 is what? 45? So that's 45 times 11 times 3. I took, what is 3 to the 2nd power? 9. So that'll leave 3 to the 1st power right here. Now why did I multiply 45 times 11? Well, 11 is close to what? 10, Hubert. That's right. So 45 times 10 is what? Plus 45 is 495, right? God, we just did that in our head. So 495 times 3. Now wait a minute. What's 3 times 500? Okay, keep that 1500 in your head. Keep it in your head. Now, what's 3 times 5? 5 is different from 495 to 500. That's different. What's 3 times 5? So what's 500 minus 15? 485. So your answer should be 485. I'm sorry, no, that's not right. 1500. 1500 minus 15 is 1485. 1485. Now, that is 1485. Now, what was your question? Now, a lot of you are saying, I know what somebody in here is saying. You don't have to raise your hand. Somebody in here is saying, what in the heck is he doing all of that math when all you got to do is put it on the calculator? Because there's these things in your brain. You know what they're called? Well, yeah. But what connects the brain cells together? Synaptic nerves. And if those synaptic nerves are not used, they go what? Dead. You ever seen anybody that couldn't make change at the cash register? That's what I'm talking about. Now, if you want to be one of those people, you keep relying on the calculators and you keep relying on, there's nothing wrong with checking your answer with the calculator. Nothing wrong with that. But this is the gym for the brain. Doing this in your head, doing this right here is calisthenics for your synaptic network in your brain. Challenge yourself. How come, anybody here like puzzles? That's the same thing. That right there, this right here is the same thing as a puzzle. Try to figure out the easiest way to what? Multiply.
Some people say, well, you could take that 33 right here, or you could multiply 3 times 3 and get 99, and that's close to 100. And 100 is easy to multiply. Instead of going, oh, I can't add that, I need to calculate it. Those people are missing the whole bus. Not just missing one thing, they're missing the whole thing. All right, let's put the answer in so we can do another one. And the reason I want to do 3 or 4 of these is because these are the ones that's going to bog you down on your homework. So the greatest common is 33. And the greatest whatever is 1485. Okay, 42 and 56. $42 and 56. They say that the lady at the IRS that lost her emails, have y'all heard that? They destroyed her BlackBerry with all her emails on it. Does that sound kind of fishy? It's all Bluetooth fault. All right, so 42 and 56. $42, 56. Well, I know 2 will go in there. That'd be what? 21 and 8, 28? And what, 7, 3, and 4? And the real math, what? Real math stops, so 14 is our greatest common divisor.
So now I'm going to take the blue marker and I'm going to divide by 3. That'll give me a 1 and a 4, 2, a 1 and a 2, and then 2, 1 and 1. There is your least common multiple. So that's 2 to the third times 3 times 7. Now, I'm not going to mess with this 8 because what is 3 times 7 close to? What is it close to? 3 times 7. What is 3 times 7? All right, what is that close to? 20. So 20 is real easy to multiply by. So I'm going to multiply 8 times 21, and 8 times 20 is 160 plus 8 is what? 8 times 20 is 160. And what's the difference between 20 and 21? 1. 1 times 8 is 8, so that's 160 plus 8, 168. And I will tell you this, if you will start using your brain a little bit like this, you will see things will come easier to you when you're doing the problem solving process versus utilizing the what? Calculator. Now let me show you where this is heading for you next class, which is whenever. Well, yeah, whenever, because y'all don't come to class when. Yeah. Here's where this is heading. 1 over 3 plus 5 over 7. Well, we don't know the common denominator of 7 and 3, so we go over here and we do 3 and 7, 3, 1, 7, 7, 1, 1. Your greatest common divisor is also your common what? Denominator. And you're going to put a 21 here and a 21 here. And 3 will go into 21. How many times? 7 times 1? 7. 7 will go into 21. 3 times 5. And you get 20, what? 2? Help me out. 22 over 21. Now, that's not for you to do in your notes. That's just for you to see where we're going with this. Do you know why people can't do fractions? Does anybody want to take a stab at it? Because they can't find that number. Or they just multiply them together, and you can't do that all the time either. And what we're going to talk about Tuesday or Wednesday or whenever is we're going to talk about how to add fractions with same denominators, how to add fractions with prime denominators, how to add fractions with prime and composite denominators. And that's what we're going to do. We're going to skip. Okay, those of you at home, listen to this microphone. We are going to temporarily skip 5.2. We're going to come back to it after 5.3 because I want to do 5.3 after this while it's still in your brain. Okay? So we're going to do 5.1, 5.3, then we're going to drop back to 5.2. Capiche? Dang, that bell don't work worth the crap. Class is over. Y'all have a good day. I'm off the clock. I'm sorry.
So we don't come back till Wednesday?
Wednesday. I guess if that's what your academic calendar says.
Wait, now that you're off the clock, did you really have
I
to
can't
do
believe that's
freshman?
already the first.
What'd you say?